to Hence the Future podcast. I'm Mattimore Cronin,
And I'm Justin Clark.
and today we're discussing the future of algorithms. And to start, I think it'd be good to address the question of what is an algorithm, and then what's the current state of the evolution of algorithms where we are right now.
Yeah, so an algorithm is really just a set of rules to accomplish something. It doesn't necessarily need to be in the context of computers. It could be like a recipe to make some food or something. But the really interesting thing about computers is the little rules that are accomplished in the algorithm are done extremely quickly. So with computers, there's a whole bunch of tiny little building blocks. Let's say it's just addition and multiplication for some computing algorithm. If you build a million of these little operations on top of each other, you can get some really cool results. So, for example, you know that computers are built on bits, zeros and ones. All of those zeros and ones are manipulated by tiny little algorithms that convert a zero and a one to something else, or a one and a one to something else. So it's just really interesting in the whole grand scheme of things. What these algorithms really are in the context of computing are just little tiny things
Yeah.
that build up to some grand thing that we know of as computers and as technology.
Yeah, I've heard a metaphor of it's like you have an infinite schoolroom of preschoolers who are all doing little like multiplication and just very simple functions. But when you add
Yeah.
up, when you have, millions of these
Mhm.
preschoolers doing small tasks for you, it can add up to some pretty incredible results.
Yeah, and I mean that's kind of what the all of this evolution in computing has been, is orchestrating these little tiny preschoolers of adding and subtracting. So now we
Yeah.
have these super powerful computers that can do billions of operations a second. And back in the day, like in the 60s, 70s, right when computers were being created, it could do maybe a few operations per second. So we've seen this exponential growth in how fast these algorithms can run because of how quickly we can manipulate little tiny bits or zeros and ones.
Right. And I think it's helpful to look at sort of where we are algorithmically on the evolutionary path. So
Hmm.
I've done some research of what machine learning experts think we're going, and
Hmm.
they say that there's basically seven stages of algorithmic intelligence. The first one, like you said, is just simple calculation. Like, let's say you have a coffee shop and it's like, okay, I know that each coffee is $1, and if someone orders
Hmm.
three coffees, that's $3. Like, that's your
Yeah.
calculation. The
Hmm.
next one, stage two, is actually execution. That's like, imagine if your coffee shop has a little button where it can just, it's coffee, and you just press that and it calculates the cost, like at any
Okay.
fast food restaurant. It's very simple. And then stage three is analysis, where it can actually tell you, oh, here's how many coffees people ordered today. And oh, people tend to really like this one. So, then you as the human being might say, okay, maybe I'll order more of this other type. Stage four is supervised learning. And then where
Hmm.
we're at right now is stage five, unsupervised learning. And that's like, the canonical example is people spending a lot of time labeling certain data inputs to a system. And now you don't have to always label the inputs. Like, you can put a bunch of images
Hmm.
of cats that you don't have to necessarily label each one. And even in an unstructured, unsupervised way, it'll be able to figure out what's going on. And the next two stages
Hmm.
are unsupervised asking, meaning you don't even have to know the right question necessarily. The computer sort of will know what you're getting at better than you do. And this is kind
Hmm.
of like when you type into Google, you start to type a question and it'll autofill the results, and it kind of
Hmm.
predicts what you want even before you know what you want. And then the
Hmm.
final stage, which we have not gotten to yet, is unsupervised action. So this would be something where not only does the AI system or algorithm know what you want and what to optimize for, it'll actually do it for you. So you could imagine
Wow.
a system where it's like, in 20 years, you wake up in the morning and you say, "Hey Siri, what's the best way for me to spend my day to achieve success for my coffee business? And then the
Hmm.
AI system will say, okay, here, I've printed out your schedule for the day. And in the meantime, I'll be optimizing, the supply chain and our marketing and everything else in the background. You just focus on this task of things, which is why don't you go meet with some of your friends and, try to get them and their AI systems helping to network. And it's
Yeah. Yeah.
so it's a really interesting progression. And if you look at where
Mhm.
we're going and how close we are to those most advanced stages of algorithmic intelligence, it's really
Mhm.
exciting time, but it's also a little bit freaky how advanced it
Yeah.
is.
Yeah, I think we should step back a little bit too and touch on the two that are most prominent right now in terms of AI, which is the structured learning and unstructured learning.
Yeah, or supervised
Because,
and
or
unsupervised.
yeah, yeah, sorry, supervised and unsupervised. So with the supervised learning, that's kind of where everything about the machine learning algorithm is dependent on the data and the labels that people give those data.
Hmm.
And the issue with this is we've talked about this before, but if there's bias in the data, so the prime example of this is inmate data. It tends to be predominantly African American data in these data sets when it comes to figuring out which people are more likely to reoffend. These machine learning algorithms become biased and just they predict that African Americans are going to reoffend more often than other races just because the data itself is biased.
Right.
So that's one of the things we need to think about is that all these algorithms perform some sort of action on the data. So we need to make sure first that the data itself is good and unbiased and
Yeah.
something that we would be happy, sending to future generations of AI algorithms.
Yeah,
Um,
no, dirty data is a huge problem, and it carries
mhm,
over the stereotypes of human society into the machine world. And when that
mhm,
happens, people tend to trust the results of this AI system, and oh, this
mhm,
is this is an unbiased system making an assessment, and so
mhm.
people trust it a lot more. But it
Yep.
carries a lot of the same biases that humans have. And
Yeah.
I was listening to this podcast, Recode Decode, with one of the heads of Google, and she was talking about how they every day they fight biases in the data whenever they notice it. So, for instance, if you search in Google CEO, you'll only get pictures of largely white men. And
Mhm.
they noticed that the first female image you got for CEO was actually Barbie CEO. And they
Oh
were
my
like, okay, this
gosh.
is a big problem. Like, there are female CEOs in the world. We got to make sure. So then they'll actually tweak the system so that, female CEOs, real female CEOs will appear sooner.
Mhm.
And so they are tweaking this to make the data more in line with
Yeah.
what our values are today.
Mhm.
But it is interesting that we have to sort of do all of this fine tuning, and the quality of the data that we put in is a huge determining factor in how
Mhm.
successful the machine intelligence actually is.
Right. Yeah, and when you move to the unsupervised learning, you not a lot of the same issues aren't really there. So one of the prime examples of an unsupervised model, or I guess you could consider it reinforcement learning. So OpenAI is really big into letting AI agents play games.
Hmm.
So the system will actually go and just learn by interacting with its environment. You don't really even give it much of a data set. It just kind of plays around and sees what happens. It's almost like the super elementary version of the scientific method, just like testing out little hypotheses. Did this work? Did this not? And
Yeah.
then over time, you get this really refined agent. The problem right now is those algorithms and those agents that learn this way are only really good at those at very specific things. They're not very good at transferring to other domains,
Right.
which is something we need to get to these future stages, like the was it unsupervised action? Was that the
Yeah.
last stage?
Yeah.
Yeah, like we need these agents to be able to learn and interact with environments that are totally separate from what they learned from, which takes, I think this is an algorithm problem more than a hardware problem. Like I think the hardware in the computing world is there. It can probably handle a lot of these really complex systems, but we just need to have more sophisticated methods of learning.
Yeah. And one of the challenges of more sophisticated methods of learning has been it's really easy when you're in a video game world because you can just play this game many,
Hmm.
many times over until it's perfect. Like, you
Hmm.
know, OpenAI you brought up just yesterday, they beat the game Dota 2, which is, like it's kind of similar to StarCraft. It's like a game where you go and it's very
Yeah.
complex, way more advanced than
Hmm.
Go or any of these other games. But the system is so good at that. And yet, when you bring it into the real world, like with robots or actual physical mechanisms, like a manufacturing plant or a car
Hmm.
manufacturer or whatever, it's difficult because you can't do the same types of learning where they're fumbling on the floor and just barely able to walk because it's a lot
Yeah.
more involved in the real physical world. So
Yeah.
one thing they've been doing recently is they try to train these systems as much as possible in the digital world, and then they transfer those skills to the real
Hmm.
world. So when you have a Boston Dynamics robot, its first steps aren't the actual first steps it's ever taken. They are in the physical world, but it's taken many steps already in the digital world. And this idea
Hmm.
of transference of learned behavior has been a big trend recently in the
Yep.
development of algorithms. And
Hmm.
just one other thing that I thought was interesting about OpenAI is that they noticed that these OpenAI systems tend to favor short-term strategies over long-term strategies. Like in this game
Hmm.
just yesterday, the OpenAI bots would revive themselves immediately, even if their base wasn't under attack, even in the
Huh.
very beginning of the game. Whereas no human would ever do that. Humans tend to they think of the long term, so they'll save their extra lives for like when it really gets
Hmm.
down to the wire. And the humans will always laugh and say, "Oh, dumb AIs aren't thinking long term," and then the humans lose. So
Yeah.
it's interesting that like AIs don't tend to have the same bias towards delayed gratification, and it actually oftentimes ends up being a good strategy because they get small gains early on
Hmm.
and then they keep those gains, and they don't have the same tendency of humans where like if you're kicking someone's ass in a tennis match, you tend to sort of get complacent and then you're not playing as hard and then your opponent will catch up to you. But AI
Hmm.
systems aren't like that. Like they keep their small like if they're a little bit ahead of you in the game, they'll keep that
Uh,
difference and build on it rather than grow complacent.
yeah, that's interesting. And this is probably a little bit to do with the way these algorithms are being optimized. A lot
Yeah.
of algorithms um, have uh, some sort of greedy attribute, which means they'll do what's good right now, even
Yeah.
if there's a little bit of delayed gratification. From a computing perspective, a lot of times it's more efficient to do something good now, and a lot of times that leads to a long-term good solution as well.
Yeah.
So the interesting thing is it's such a different way from what we how we think. But a lot of these algorithms are supposedly based off of how humans learn. So, for example, this transfer learning would be like how the human brain develops in the womb. There's a little bit of a neural network, there's an architecture in our brain that's being developed that gives us some sort of behavior. So we know
Right.
kind of what to do when we make it
It's like
out of the
nature
womb.
versus nurture.
Yeah, I mean, and then the nurture part. So the nature is what these algorithms learn in their robot space. The
Right.
nurture is what they learn from interacting with the real world. So it's like there's a
Yeah.
lot of parallels between how humans evolve and how these systems evolve. And really, I mean, we're little algorithms too. Like we have these set of rules that will get us to the next generations.
Oh
So,
yeah. I mean, it's very telling that there are biological exploits
mhm,
for that algorithms can take advantage of. So anyone who's read, the five principles of persuasion, reciprocity, scarcity, social proof, exclusivity. All of these things are ways that you can hack human behavior because we have an algorithm inherent in us, and
Yep.
other algorithms are able to optimize and iterate a million times over until they can find the best way of exploiting those those algorithmic predictable behaviors. And one thing that I think is very telling is that the most effective AI systems have been ones where there's an actual score for how well they're doing. So
Yeah.
oftentimes it's a game, video game, it's a board game, it's whatever. And I think that that is going to be the key in how advanced a lot of these algorithms can get, because if we're able to actually judge how advanced they are or how well they're doing, then it'll be able to achieve its goals much more readily. And I actually think that this might be part of the reason why China is starting to leap ahead of us as far as their AI capabilities, because they are, by 2020, they're going to have this social credit score, which
Yep.
it's pretty transparent. It's been put into law as far as what the factors are. And it's, if you're doing something that is considered something a good citizen would do, your score increases. If you do something that's considered something a bad citizen would do, then your score decreases. And you can imagine that this could be one of the fundamental building blocks that their AI systems are centered around. Like if you have AI systems that are all centered around rewarding people with a higher score and punishing people who have a lower score, that's a really efficient fabric for society, just technologically speaking, for their AI
Yeah.
systems. And I wonder how that's going to compare to the US system, where there's not as clear scores for how well people are doing as citizens and how well machines are doing in their ability to help the citizens that they should be helping and punish the citizens that they should be punishing.
Yeah, and that's kind of the trouble with getting these AI systems to function well in the real world is we don't have the real world has so many rules and maybe even contradictory rules. But I mean even the laws of physics, that is a set of rules that agents need to obey somehow. And they also have we have a set of societal rules and laws and culture, cultural rules that these AI systems need to follow. So with a game, let's say you have a set of, I don't know, 10 rules and a very clear objective. When you bring this agent to the real world, it's millions of rules potentially and not really even a clear objective unless you explicitly tell a certain system what it needs to do. But even then, there's a lot of sub-objectives, which is also true
Right,
sometimes in games. But that's one of the things that I don't think classical computers are equipped to handle. I think the
right.
amount of computing power necessary to solve that optimization problem is totally infeasible right now, which
Oh
points
yeah.
to maybe a quantum computing system that can simulate extreme numbers of rules because it's computing the computing substrate or like the materials that it's computing on or moving data around on are way larger. Like the space that it can compute on are much larger. So with quantum computing, they can the computers can theoretically run computations on these particles that are entangled and have all of these wave slash particle properties, whereas classical computers are just voltages of high voltage, no voltage. Like that's where the 0 and 1 comes from. So we just need a totally different way of computing, I think, to be able to optimize and reach this general AI or super intelligent system that we're
Yeah.
hoping for.
No, I agree. Machine learning is going to be a big X factor in how much we're able to accomplish in the next 20 years or 50 years. It's worth noting how far we've gotten with unstructured data with classical computers. Because,
Hmm.
for instance, like if you look at Google PageRank, which came out in like the late 90s,
Yeah.
compared to Rank Brain, which is the current system in Google, it's
Mm-hmm.
night and day. So PageRank is very simple. Basically, it will scan your page for keywords like, oh, coffee shop, Los Angeles, whatever. And then it just associates that with whatever the search is. So if you search, oh, coffee shop in Los Angeles, you'll show up, which is
Mm-hmm.
very simple. But this was easy to game. People could just like put the keyword a bunch of times. The
Yeah.
difference now is that Google actually understands the concepts behind what you're saying. So it will automatically not just load coffee, but it'll load espresso and whatever, workplace, study place, good Wi-Fi, like
Mm-hmm.
anything that's associated with it. And
Yeah.
that is all based on unstructured or unsupervised learning. And
Yeah. It just kind of learns as it goes.
yeah, so it's associating like what are you really trying to find,
Mm-hmm.
and then it'll show the importance of the different results based on other people's bounce rate if they've actually found what they wanted and if
Mm-hmm.
they haven't. But quantum computing is the next big leap. And the thing about quantum computing, as you've expressed, is that something doesn't have to be either true or false. It can be true and false at the same time. And oftentimes, when you get into the messy real world, that's the way that the world actually is. I mean, there's almost nothing you can say with certainty. Like
Mm-hmm.
anything you say, the opposite is also true because words just cut things into what
Yeah.
they mean and what they don't mean. And by that definition, they're not encapsulating the totality of all that's out
Mm-hmm.
there. So, yeah, I think it's going to be. Plus, the other thing about quantum computing is that it's really our only option in the face of Moore's law ending.
Yeah. Well, there are a couple of obscure things that are being tried, like molecular computing, like
Oh,
encoding information in DNA, trying to run some sort of computation on the information in DNA, or like molecular computing.
oh, that's
Because
interesting.
really, algorithms are just a way to manipulate information somehow. So if we can encode this information in different, more novel ways and maybe more compact ways. So let's say with 20 qubits, which is a quantum bit that can be, like you said, a true and false at the same time, and any combination of true and false. So it can be like 30% true, 70% false, or vice versa, and every infinite possibility in the middle of that. Um, with with quantum computers, if we can achieve some sort of, or if we can manipulate particles better and we can encode information in these particles, then we're going to be able to run better calculations, better algorithms. But the negative side of quantum computing, though, is they're very bad at super basic things. Like, so they're good at probabilistic things. They're not very good at what classical computers are good at, like adding.
Hmm.
So with a quantum computer, if you try to add something, you're going to get like, if you add 2 plus 2, you'll get a probability that it equals 4,
Hmm.
that this equals 4. It's going to be
Yeah.
highly likely, but it's way more computing power than you need. So I think there's going to be some sort of hybrid system where we need classical computers. We also need quantum computers to do certain things like simulate physical systems or run
Right.
these crazy optimizations.
Yeah, and I've heard that optimization, those really are the types of problems that are best solved by quantum computers. So
Hmm.
if you're trying to find what's the best planet that's the most like Earth for us to go potentially colonize, that's a great
Hmm.
problem for a quantum computer because it's going to find whatever the best option is in the least amount of time
Hmm.
based on like lots of uncertainty around whether
Yeah.
it is or isn't exactly like what we're looking for. Or a similar one could be, finding the right sort of medication for your specific genome. So if you have a
Hmm.
specific strain of cancer, what's the right sort of medicine for you to take based on all of those factors? So, or like, I'm a marketer. If you're trying to find, okay, what's the right sort of advertising image and message and link and every other factor, call to action
Hmm.
for this objective and this audience, like that would be a great problem also for a quantum computer. because there's
Yeah.
just so many combinations that a classical computer would take forever to get there.
Yeah, and that's one thing that I think would be interesting to talk about is the speed of certain algorithms, because I think a
Yeah.
lot of like the general public doesn't necessarily think of speed being an important thing in terms of writing algorithms. So if you try to think of a way to sort a list of numbers, for example, that's kind of like the canonical example when you're learning algorithms. If you just do a brute force method, like you just write the most intuitive thing that seems to work for sorting, it's really slow. But if you start to break down the problem in really novel ways, you can make things run a lot faster. But sometimes, so there's an entire field in computer science called algorithmic time complexity, or variations of that, um, where basically people try to figure out what is if you if you increase the number of inputs to infinity, like how does the time of this problem scale with the number of inputs?
Hmm.
And one example of this is something called the traveling salesman problem, where the problem statement is given a list of cities on a map and distances between these cities. What is the shortest possible route to hit every one of these cities and then
Oh.
end up at your home?
So this
So
is
it
like
turns
basically the same problem that Uber and Lyft have to solve every single day, but
Yeah,
not as optimally as they are like right now, as they
yeah.
could
Well,
be.
the thing is with the traveling salesman problem is it's exponential in time, meaning that if you have 40 cities, the time complexity is 2 to the 40 operations.
Wow.
And that's, I mean, it's not even that many cities. And if you add 50 cities or 100 cities, you start to have more operations than it would take if a computer had the entire time of the life of the known universe.
Right. Well, I've
So,
I've
like,
also heard that in Go, there are more combinations, more
yeah,
possible moves than there are atoms in the universe. And the fact
yeah.
that a computer can already beat Go shows that this method of learning, even without quantum computers, is very effective. So I
Mhm.
guess my question to you is, what can machine learning accomplish that unstructured learning cannot? Or is it
So,
just a matter of the how much better, like this the scale, the magnitude of its efficiency and efficacy?
yeah, I mean, it depends on what the problem itself is. So, with the traveling salesman problem, it's a very um, you can get good approximations of the answer to this solution, but you're not guaranteed to know the exact optimal solution. So with machine learning, what they're very good at doing is approximating the correct answer. It doesn't necessarily know the exact right answer for every input ever, but with machine learning, it can kind of learn all of these different uh, parameters that are, how are things related to each other? How do these different inputs relate to one another, and how does that affect the output? And machine learning is kind of this, all of them run some sort of, or not all of them, but like neural networks, or what you think of as AI, are based on neural networks, which are sort of approximations of the globally correct or right solution. So there's a lot of approximation going on. But with quantum computers, we are potentially going to have globally optimal solutions to these problems um, that machine learning in its current form can't solve. But there's
Yeah.
this whole field of quantum machine learning. I think Google has a quantum AI lab
Right.
that they're trying to, because, so just for listeners, machine learning, especially like neural networks and deep learning and that subset of artificial intelligence, is all the algorithms that optimize these things. Everything coming from OpenAI is probably based on a neural network to some extent. All of these are being optimized through some sort of approximation algorithm,
Yeah.
or some sort of approximation. Um, well, okay, yeah, some sort of algorithm that isn't necessarily right. So with when there is quantum AI group that's working on this, we might, we probably will be able to see globally optimal solutions very quickly.
Yeah.
Um, so yeah.
Yeah, and I want to talk a little bit about the big players in this space, not just quantum
Mhm.
computing, but machine learning and just the forefront of algorithmic evolution in general. And it seems to me like there are basically just this, a few big players. There's Google, Google's
Mhm.
Deepmind, there's OpenAI, there's Amazon, Facebook, Microsoft, and then China. They're all sort of connected within the nation state. So it seems like those really are the big players. And when I was doing just some industry research, it seems like any AI startup worth their salt just gets gobbled up by Google or Amazon or Facebook or one of these guys. So it does seem to me when you're thinking about who are going to be the likely players that will come out with the next great algorithm that may be more intelligent than anything we've seen before, it seems likely it's going to come from one of these players. I'm curious if you have any thoughts on what's different about them. Are there differences in philosophy between these players? Are there differences in their capabilities or their approach or how far they are along? I mean, how do you see this space?
So it's hard to know without like seeing what their day-to-day operations are, but I do think in terms of machine learning, there are a very specific set of problems that are trying to be solved by these all of these companies, and games are kind of the forefront, and natural language processing things. So how do we understand what a certain sentence actually means? That's a really hard problem for computers, but OpenAI actually released something that can generate super realistic text. So much so that they didn't even release the source code.
Wow.
Um, so, in terms of AI, I think the approaches are probably similar. I think there's a lot of overlap too in the staff themselves. I think there's a lot of faculty, like Jeffrey Hinton, who's kind of he's one of the fathers of modern deep learning. I believe he works for Google Brain and University of Toronto, and maybe advises for, I don't know this for sure, but I think he advises for maybe a couple of other groups.
Hmm.
Um, so there's a lot of overlap, which means there's sort of some sort of uniformity between people, or between these
Right.
organizations. Um,
Yeah.
and this is in terms of artificial intelligence. Now you also have these different companies that are doing different types of quantum algorithm, or quantum computing. They're trying to develop different methods. So Microsoft is developing a totally different method of quantum computing than Google or IBM or some of these other startups like Rigetti or D-Wave. So I think with
Mm.
quantum computing, people are approaching it, or companies are approaching it in much different ways. Like Google is trying to make quantum computing possible on a silicon chip.
Hmm.
Um, and Microsoft is mostly theoretical. Like they're trying to create something called a topological quantum computer, which is supposed to make it much more stable. But it's totally theoretical, and there's not really any hardware open to the public, as far as I'm aware.
Well, I found the same thing in my research where it seems like there are the same sorts of DNN models that are being used by all the big players or they're
Deep neural networks for listeners.
yeah, so there's just a few really popular models and it seems like we don't yet know all of the assumptions necessary to have the optimal machine learning system. If we
Right.
did, then it would be a lot more prevalent than it is today. It wouldn't just be video games. It would be everything from healthcare to business to everything else. So
Mhm.
it seems like this is the kind of problem that can't be solved by a lone hacker in their basement or by
No.
a small startup that doesn't have a lot of runway. It needs
Yep.
to be solved by a company that can really invest in long-term thinking, the theory behind it, being able to, fund it for a long time. Um,
Mm.
and, it would be good to sort of project out on how we think this space can develop going forward. So I don't know how soon you want to get into the future scenarios, but I have a lot to say about those, unless there are some other big trends you want to address first.
No, I mean, I think it would be interesting to start getting into the scenarios, and we can have a discussion about each of them.
Okay, sweet. Well, let's take a quick break and then get into the future scenarios. All right, so Justin, what do you think is the worst case scenario for algorithms?
Worst case scenario.
So if we go way far out and we think of algorithms and what the potential of algorithms are in the future and what the potential of computing is in the future, let's say that we don't have to get into the whole simulation discussion right now, like are we in a simulation? But at some point, if we have quantum computers, we're going to be able to simulate physical systems that are entirely realistic and plausible just within a computer. And through these simulations, as they get better and better, we might be able to simulate entire worlds such as our own. And if we can simulate these worlds, but we don't really care about what's happening in these various simulations, some of those scenarios might be people and organisms that go through an unimaginable amount of suffering. But they're conscious because it's a simulation that's so good that it somehow spawned intelligent life and conscious life. So
Yeah.
I think as simulations get better and better, we have the potential to create an unimaginable amount of suffering without even knowing about it.
Yeah, I'm a little skeptical about that. I think it is possible with quantum entanglement. Like, for instance, you could imagine having an advanced simulation that is supposed to simulate society, and due to quantum entanglement, you're actually sort of pulling the strings on another dimension and real conscious beings and what their experiences are like. But I think it might be a little, I mean, yeah, maybe down the road it could be so advanced that it could actually create suffering for real beings, but I'm a little skeptical on whether that is something we should worry about right now. From my perspective, the big concern is whether algorithms unite people and empower people, or whether algorithms divide people and extract value from people. Because if you think
Right.
about the most prominent algorithms today, they're all about extracting value from people.
Yeah.
I
At
mean,
least most of them.
yeah, not all of them, but
Yeah.
the most prominent ones,
Yeah.
Google, Facebook, you could even think of like financial algorithms, something we haven't talked about yet. But these are all meant to extract value from people. Like if you think about the stock market and how programmatic trading works, which I know you're well familiar with, um, basically what happens is as some citizen makes a trade on a financial system, that trade happens very slowly relative to people who are actually investing in having the fastest systems and the servers that are closest to where the actual stock market exchanges are and all of that. So from the time that you put in a trade to the time that you actually get the price of the trade and the stock is secured, you've already been undercut many times over by faster systems that are making money just off of those slight fraction of a
Yeah.
second improvements, and just under, and that doesn't create any value in society at all. And in a
Yeah.
similar way, Google and Facebook, and so, I mean, I actually think Google's algorithm is pretty beneficial compared to the other players. But if you look at
Yeah.
like Facebook's algorithm, it's really all about engagement, keeping you engaged. Same with
Yeah.
YouTube,
YouTube. Yeah.
as much time as possible watching this. And the real reason that they want you to spend as much time as possible is so that they can extract as much value from you as possible in the form of advertising time watched and in the
Yeah.
form of actually buying stuff on the platform. Like, the more time you spend on your iPhone, the more apps you buy, and Apple gets a 30% cut of all apps. And every system works in this way. Amazon works in this way,
Hmm.
Apple, everything is trying to get you to spend more time, spend more money, extract more value. And I think that's a theme that we can broadly say across all algorithms seems to be dominant right now. Now, actually, maybe I should save this next part for the best case scenario. But
Yeah.
so I will save this. But yeah, is there
Yeah.
anything you have to react to that?
So it really just depends on what, so you, when we're thinking about what type of companies we want to allow in our lives, I think we just need to think about what that company's true intentions and what their financial incentives are. So with, let's say Waze, for example, they might, I think, are they owned by Google?
They are, yeah.
Okay. Well, let's just think of them as a standalone brand for now. With Waze, what are they trying to do? Get you from point A to point B. I'd say that's a pretty good algorithm. It's not really doing anything except saving you time, which is good. Like there's a lot of algorithms that save time for people. It's just especially when we're dealing with companies like Facebook, Twitter, and Google to some extent are trying to keep you and essentially control your actions to some extent. That's when we see the real problem.
Yeah, and I don't think their intention is to control your actions so much as it is to predict your behavior. But the better they get at predicting your behavior, the more they're actually driving your behavior.
Yeah.
It's like every algorithm is sort of trying to put you into a bucket of like, oh, you're this type of person. And then they feed you more content that that type of person tends to like. And then you become more hardened in that type, that archetype, rather than being a nuanced person that has, many different personalities and beliefs and, just being a healthy human being that has many different opinions on many different affairs. And it's not all driven by one underlying ideology. It seems like now people are being pushed more into their ideological buckets so that they can have a value extracted from them.
Yeah.
And I also worry that the highest growth areas of the internet seem to be those that are very passive as far as how humans interact with them. Like it's watching Netflix, it's consuming social media, it's scrolling through your threads. It's not about you actually being a better creator. And of course there are those tools are out there as well. It's never been easier to start your own YouTube channel or entertainment studio or blog or book or anything like that. But if you look at the numbers of how the vast majority of people are spending the vast majority of their time, it's being spent very passively, and any sort of passive activity is ripe for trained behavior, learned behavior. In other words, you as the human being programmed, as opposed to being the one programming and affecting what you want the reality to be like.
Yeah, I mean that's it. That definitely seems like a near-term worst-case scenario. Mine was kind of like probably hundreds of years down the line potentially, but
Well, maybe not. I mean, so I watched an interview with Elon Musk, and he talks about the Google Deepmind as one of the doomsday scenarios that he is most concerned about. And the reason he's concerned about that, by the way, he's an investor, so he's
yeah,
keeping an eye on them, thankfully. But the
yeah,
reason he's concerned is that Google's DeepMind system has admin access to all of Google's data, which is basically like all of humanity's data, a
yeah. I
large
mean
portion
even
of it.
health information.
Oh yeah, and when you associate it with people's Gmail accounts and all the information in there and in Google Docs and Google Drives and just the whole Google world, there is so much information they can draw from that if you imagine that this system, when it becomes so advanced that it's not like it becomes evil, like machines aren't evil, they don't have the same drives that humans do. But if it has an objective that just happens to be in the way of what people would actually want in their lives, it'll stampede over those desires, just like how a construction site stampedes over an anthill, not because it hates the anthill, but because it just happens to be in the way of the building that it's trying to build. And
Yeah,
if something like that occurs, just due to how much wealth of data and information Google controls, it would be able to fundamentally change society in ways that are hard to imagine.
Yeah, I mean, if you just think about how extreme, so let's think about the how extreme AI could potentially be in the future. It'll be amazing at whatever it's trying to do. If the incentives and goals are just a tiny bit misaligned from our own, that can cause catastrophic downside effects in the future.
Hmm.
Because just if you just take a tiny little difference of opinion or a difference in incentive or goal and put that to the extreme, I mean, that's similar to how a lot of things are, today in society. There's just tiny little differences that get pushed to the extreme. And that's just, I would say that's still a minor level compared to what it'll be when AI and human agents have just slightly differing goals.
Yeah.
Uh,
And it's definitely worrisome that the most powerful people in the world, like the tech billionaires,
mhm.
are having doomsday plans for, oh, I'm going to buy this house in New Zealand or Alaska in case everything goes to shit. And they all talk about their plans of like getting on their motorcycle and driving up to their cabin in Big Sur where they have like food stockpiled and EMP protection. And it's like,
Oh my gosh.
okay, if these are the most powerful people in the world and they're prepping for the scenario that they're effectively creating, like what does that say about the future of algorithms?
Oh, yeah, I mean, so the optimist in me would hope that this is just them hedging, or maybe they're a little bit overly alarmist about it.
Well, I think it
I don't.
shows that a lot of these trends aren't something that humans really have much power to change. It's like we're going to achieve greater than human level intelligence in machines, regardless of what any individual wants. So,
Mhm.
to a certain extent, it's not really within any person's control to put a pause or to slow down our level of progress. So, even the people who are, especially the people who are most knowledgeable in this space, know what could happen if it goes the wrong way. And
Mhm.
that should put all of us on notice that we should be actually concerned and aware and paying attention to this space. And it
Yeah.
may not be, of course, the most likely is that it's not going to be as bad as what these people are prepping for. But just the fact that it's a possibility is pretty scary.
Yeah. So let, let's transition into the best case.
Best case scenario.
So I think the wrong way to approach this would be to explicitly tell an algorithm or an AI system what its goal should be. I think it should learn what the goal should be. And there's a lot, so with reinforcement learning, which is a version of machine learning, a lot of times it goes in with no goal
Hmm.
except for to learn the goal. Like the learning, one of the learning um, steps in the first place should be. And one of the nice things about today is we have a lot of written, recorded. So what we're doing right now is information for a future AI system to learn about the motivations and the wants of people. So, I'm sure at some point in the next 20 years, it will dissect what we're saying right now to try to optimize what it's going to do for the human race. And it's going to do that for every written piece of information. Some are probably going to be um, weighted more heavily than others. Hopefully, there's a way to discern that, and I'm sure there would be a way to discern, if there's a good or a credible person from a non-credible person. Um, so, anyways, I think that if the AI system can learn from this mass that is everything digital, then it will be able to align its incentives with us and with humans in general. And if it can do that, even if it has to act differently for different people, I think, we can see a world of unimaginable prosperity. Um,
Yeah. I mean, the big thing the big concern that I have is the black box nature of these algorithms, because that
Hmm.
can lead to a runaway train cart where we don't really know how these machines work, but they've become so valuable to society that we wouldn't dare turn them off. And then that leads to a situation where we're not really in control of our own destiny anymore. So
Yeah.
that's my big concern. So in light of that, my best case scenario includes the ability to query these AI systems and these algorithms to ask them why they made a certain decision and to
Hmm.
get a comprehensible response from the system. So to say, like, Siri, why have, Siri, why did you choose this as my schedule for the day? And they're like, oh, blah, 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 blah. Or Siri, does this system discriminate in any way against this group of people? Like, to be able to
Mm.
just ask those simple questions and get a response or get some sort of report is going to be huge in our ability to actually steer the direction of the ship. Because if we cannot understand what's inside the black box and all we can do is give data inputs, then we have very little control in what is going to come out on the other end.
Yeah. So to play devil's advocate a little bit, do do humans really know why they made certain decisions? Like human brains are
No,
also very black boxy.
but we know what motivates humans.
For
By
I
and
would say we
large,
think I would say
it's
we think we
survival and
know.
reproduction. It's like that's basically it.
Yeah,
It's
but
also
then
the will to meaning, which is what makes humans the most unique. Which
yeah.
which is that, like, I don't know if you ever heard of logotherapy?
No, I haven't. What is
So
it?
it's pioneered by Viktor Frankl, which is a different kind of therapy where it's not about like building up your ego and your ego narrative. It's all about your search for meaning, and it takes as fact that every person's fundamental goal is the will to create meaning in their own life. And this is really what's a fundamental androidism as opposed to algorithm. Like, what makes us really human is that every person is trying to sort of find their place in the universe and trying to find and create meaning in their own life. And
Hmm.
logotherapy is basically just the process of saying that it's not about you asking life, like, what's the meaning of life? It's more about in every moment that you live, life is asking you how you're going to create meaning by your response to whatever your current situation is, whatever the current circumstances are. So basically, it's like, are you the type of person that is going to take on these hardships and this suffering and turn it into something noble? Or are you the type of person that's just going to wallow in self pity? And part of the therapy is that pretend like you've already lived life once and you're about to make the same, like, you've already made the same mistake that you're about to make right now, and this is your
Hmm.
second chance at life, and you can actually respond in a way where you create your own meaning. So I think that gets fundamentally at what it means to be a human being, is you're always like taking all these inputs and trying to create meaning for yourself and your place in the universe, and trying to figure out why you do certain things. And
Hmm.
that's not something that's fundamentally baked into algorithms. Algorithms are, they just they, like you said, a lot of times you'll give them an objective and they do whatever to get to that objective, but we're only
Hmm.
now getting to the point where there's this shifting objectives and shifting of questions where algorithms really get more at what are you fundamentally trying to get to. Like, maybe the
Hmm.
assumptions, maybe the questions weren't phrased perfectly, so I'm going to change those assumptions, I'm going to change those questions, and then I might even change the goalpost a little bit, because what these humans are asking isn't really what they mean to be asking. And this is one of the greatest potentialities of AI and algorithms, but it's
Hmm.
also one of the greatest dangers, because we may not be able to, choose the goalpost, essentially.
Yeah, that's interesting. And maybe right now what we understand as AI we can compare more to like a reptile that doesn't really know anything. It just kind of reacts to its environment. But what we haven't done is created the AI counterpart to the prefrontal cortex, or the latest stage of the human's brain that gives us this self-awareness and this planning and this, all of this stuff that we were just talking about. So maybe at that point, once we have a sophisticated enough method to encode these, these learning machines, then, maybe we can get to that point where we do have systems that can even have, well, I don't, yeah, kind of like you said, it would be bad if it had its own goals and then those goals diverged from us. But
Right. I mean,
yeah, that's a
as
hard
I look
problem.
forward into what I think the best outcome would be for the US in particular, I think it is going to be necessary for us to have some sort of overall score for how well people are doing, similar to China's score, because the
Mhm.
alternative is to have some way of measuring people, but it's just not transparent. Like people don't know what the actual inputs are. Like people are being
Yeah.
measured, but it's sort of behind closed doors. So if we did have some sort of social credit score in the US, but we encoded our values into that score, like we have freedom of speech as one of the values. Like imagine if
Mhm.
we had a similar thing to China's social credit system, but you could say whatever the hell you want so long as you're not spreading misinformation or hate
Mhm.
speech, then that would be a fairly good outcome for society if you also value things like free will and privacy to some extent. If
Mhm.
you encode these things into the system and then have a score that is transparent, people know why they're getting the score, and then you can set up society in such a way that it reinforces people to do behaviors that are deemed good by that society and to discourage people from doing things that are deemed bad in that society. And you have all of the key values represented in the system, then that to me seems like the most successful long term outcome for America's algorithmic governance.
Yeah, no, I mean I would say that's definitely a good place to be. And then in the long term, if everything works out, then that'll just bring happiness and prosperity to everybody.
Right.
So
Well,
that's
to everyone
that's
who's willing to at least change their ways.
I guess that's true. At some point, there's probably going to be a situation where you're in a huge disadvantage if you're not, accepting of some of the new changes, which I'm sure will be a lot more intrusive because a lot more data is going to be tracked. Um, it just depends on what is the source of this AI system? Is it a decentralized thing that's kind of running on everybody's computer that shares the resources of everybody that has a phone or a computer or something else, or is it being run primarily by Google or Facebook
Yeah.
or something? That's
I think because the US has a big bent towards the private sector, it'll end up being a private company that'll provide the service, but they might partner with the US government as, their provider of that, society analysis service.
yeah. I don't know. That's interesting to think of where that could lead, or
Yeah.
what.
But I think like I mean, one of the biggest checks on algorithmic decision making has been the employees themselves. Like Google employees had a big walkout when Google tried to do, build surveillance technology for, some of the government. And so I think this is one of the big safeguards that we have. And if we can continue to empower people to really think about what should the incentives be, what should the right outcomes be and the right inputs be, rather than just focusing on making the system as engaging as possible, which is basically what we're optimizing for right now. Like how many comments are there? Like that's like the number one engagement metric across most of these algorithms. If instead we focus on, the context, the accuracy, and the best possible outcomes, and if we get to a point where a lot of these algorithms can run most of the mundane processes, and then humans and engineers and philosophers and policymakers can really just decide what is it that we want, and if we have the ability to tweak the system and query the system about why certain outputs are being generated,
Hmm.
then that's a good formula for long-term success. And those are a lot of assumptions, but I think it is possible for us to get there.
Yeah, I mean that's in I guess in terms of the likely scenario,
Most likely scenario.
I'm I'm more optimistic about this topic than some of the others we've talked about. I think it with me it tends I'm more pessimistic about environmental things and more optimistic about technological things, which might be, my own bias leaking into uh, these these things. But I
Yeah.
think in the likely scenario, we have something similar to what you were talking about, where we have this committee of people that are trying to figure out the best way to use AI as a governing system. Um, I think what I do think is we'll probably get it wrong a couple of times, but with all of the advancement, I think that at some point we're going to be constrained by the technology, so it's not going to increase as quickly as we might have thought, but that also gives us time to iterate, shut it down, do what we need to do. So I think with this sort of progression, and especially the people that are making these systems tend to be more progressive and less power hungry than some other um, sectors will be. I think we'll probably be in a better situation long term, and I think that they will figure something out related to it, because there are so many people that are concerned about the future of AI. I think that people are going to have to listen to the public and the experts on the subject.
Yeah, yeah, I agree with your assessment. I think that not all companies are going to be totally beneficial with the way that they write their algorithms and with what they're optimizing for. But
Hmm.
I also think that people are much more cognizant now of what the different privacy philosophies are of these companies. And Facebook has been called out time and time again. They just came out with this new transparency tool where you can actually see which companies have uploaded your personal information to custom audiences. And
Wow.
it's pretty scary because you can see why does this Maserati dealership in Simi Valley have my email and phone number? Like, how did that happen? But just the fact that the trend is going more towards transparency, and especially if you look on Twitter, I mean, people are calling out companies every day for doing something that's not kosher from a privacy perspective or a discrimination perspective. So I think it's going to be the survival of the most beneficial algorithms,
Hmm.
which is a good sign. And I think Google is probably the best positioned of all of them just because of their philosophy on an open system, and they're really actively combating bunk data and discriminatory outcomes, and they have an
Hmm.
ethics board that does seem to have some real power. It's not just ethics theater. Like, a lot of people have said that Facebook's ethics board doesn't really have much power. It's just really for PR purposes.
Yeah.
And so I think that's a trend that some companies will have ethics boards, but they won't actually have decision making power. Um, so yeah, I think the most likely outcome is a good outcome for humanity. And I think that in the end, we're going to have a more efficient society that is a more equitable society, I should say.
Mm.
And I think that there's also going to be a trend towards focusing on the long tail and on discovery rather than on the short head, which is like, if you think of Spotify, the vast majority of listens are for, the top songs like Ariana Grande, whatever
Yeah.
like the top artists are. But then if you look at something like Bandcamp, and Bandcamp is all about independent artists, long tail discovery, and their discovery algorithm is not based on what's the most listened to. It's based on giving you something new that you may not have discovered. So they don't prioritize things that have been listened to a bunch of times. They make sure it's related to whatever you currently like, but they don't give any prominence to the number of listens. So that
Yeah.
algorithm is fundamentally different. It's all about sort of discovery and curating and connecting with individuals. And I think we're going to see a lot more of those types of businesses especially as we get to a post-automation world where, you know, everyone could have their own book, their own podcast, their own little coffee shop, their own little whatever. And it's not like people need all of these extra shops, but by highlighting the human-to-human connection, you can then choose, okay, who am I going to buy my books from, or my music from, or my whatever from? I'm going to buy it from the people who I have actual emotional connections with. And it'll become sort of like almost an advanced technological way of getting back to the original sort of bartering system. And we didn't talk at all about blockchain, but I think blockchain has some big potentialities to decentralize and really focus on circulating value rather than extracting value. Like that's one theme I kept coming to again and again, which if we can focus on like people trading with one another and money going through society rather than people like sucking up money like a vacuum cleaner and then it's
just
not
hoarding
being
it.
Exactly. And then like the stimulus plans or the government pumping more money into the people that already have these hoarded stockpiles of money rather than doing something from the ground up, which is like UBI, which gets hated on all the time, even though it so clearly has advantages compared to the trickle down process that we pretty much know doesn't work. So I'm very hopeful. I actually feel very optimistic around algorithms, more so than many of our other topics. And
I guess there might even be at some point room for a part 2 to talk about these, because we focused a lot about artificial intelligence in this one, but it would be good to talk a little bit about some of the other prominent algorithms, like the blockchain related stuff that you just brought up, because you know that's maybe even a podcast in and of itself. Is just
we should for sure
about it.
I mean, we could do a whole episode on the future of finance and money, because money is like the operating system that we don't even realize it's the operating system of society, but it has so many implications as everything else we do. And if we just replace this operating system with an improved update that focuses on circulation rather than value extraction, I mean, it could just work wonders for the economy and society and inequality and everything.
Yeah, that'd be good. And of course, all of that will be run by algorithms. And just to make one final point too, is algorithms are fundamental to everything. Like every piece of software you use is fundamentally an algorithm. Everything you do in real life is an algorithm. So if you can improve your own algorithms and your own decision-making processes in real life, you know, that can lead to an improved outcome in the long term for you individually. So if you make a rule or an algorithm, like not to drink Coke or something one day a week, if you're a huge Coke drinker.
Look, it's like, what are the benefits of meditation? It's really improving your algorithmic decision-making capabilities. It's like, if someone calls me a doofus, am I going to punch him in the nose and then get sued and go to jail and have this cascading negative effects? Or am I going to take a deep breath and just think kind thoughts about him? Like, you know, so I agree. Algorithms pervade everything, and I look forward to the continued advancement of not only computer algorithms, but also human decision-making algorithms.
Yeah, couldn't have said it better. Maybe that's a good place to wrap it up.
Yeah, awesome. Well, thank you everyone for listening. This has been the future of algorithms.
We're going to talk about what has happened,
we hope to see you next time.
What is currently happening, and what will inevitably happen.
The past, the present, and the future.
Our computer is picking up a strange signal.
The past, the present, and the future, baby.
What's the world coming to?
The past, the present, and the future. The past, the present, and the future, baby. The past, the present, and the future.
Will attempt to stimulate consciousness.
The past, the present, and the future, baby.
Behind the strange signal is an alien intelligence.
The past, the present, and the future. The past, the present, and the future.
you.